Hello everyone. So when we were studying the transient analysis, we have solved this circuit, right? And how did we draw the current waveform? First we draw the voltage waveform and then we differentiate it and then get the current waveform, right? But now we will do it intuitively because while studying that topic, I told you that I will be solving it intuitively later on in the course. So now it's the time. Okay. So let's solve it intuitively. I hope you know the voltage waveform, right? So tell me at t equals to 0, what happens? This C will be shorted, this T 2C will also be shorted. So there will be infinite current, right? There will be infinite current flowing. And if there is infinite current, that means sudden change in capacitor voltage. Sudden change in capacitor voltage. Okay, so let's just call this as VC2 and this as VC1. So at t equals to 0, IC1 and IC2 are what? Impulsive, right? At t equals to 0, IC1 and IC2 are impulsive. Why so? Because there is infinite current. Infinite current means impulsive current. So at t equals to 0, IC1, IC2 and IC1 are impulsive, right? Now, how can I find the value of current? So tell me, VC0, what is VC0? 0 minus you can say, it is 0 volt. And what is VC2 0 minus? Before this input voltage, it was 0 volt only, right? Tell me what is VC1 0 plus? What is VC1 0 plus? That will be 2C by 3C into 5 because voltage is divided in the inverse proportion. So 2C by 3C into 5. So that would be 5 by 3 volt. And what will be VC2 at t equals to 0 plus? That would be C upon 3C. C upon 3C. Okay. So it would be, this would be 10 by 3 actually. 2C upon 3C into 5. So this would be 10 by 3 volt. And this would be 5 by 3 volt. I hope you are already aware of this concept because we have already studied it in transient analysis, right? So what is your IC1 at t equals to 0? That would be C dVc by dt at t equals to 0. That means C1 I can say C1. What is the value of C1? C1 is C. Change in capacitor voltage with respect to time. Change in capacitor voltage from 0 to 10 by 3 into 10 by 3. Divide by time. From 0 minus to 0 plus. Time is 0 only. And if the time is 0, that means it will become delta t. So simply what is the current? The current is 10C by 3 delta t. Are you getting my point? How did I write the current at t equals to 0? This is not the current at t equals to 0 plus. Mark my words. Circuit at t equals to 0 plus will look something different. This is the current at t equals to 0. At t equals to 0, the complete circuit is shorted. That means there is infinite current flowing. And because of this infinite current, that means the current is impulsive. How do you find the value of that current? That first you see what was the voltage before, it was 0. And after that, the voltage is 10 by 3. So what is our current? Current is simply CV into delta t. If there is impulsive current, that means the amount of charge it has developed in no time. In no time, it has developed this much amount of charge. Initial charge was 0. Now the charge is 10C by 3. So it has developed 10C by 3 charge in no time. That's why this is the current. We have understood all this concept very, very deeply in transient analysis. This is kind of revision. The main task here is to find the current at t equals to 0 plus. Most of you must be already knowing this value, right? And what will be IC at t equals to 0? IC2 at t equals to 0. That would have also been 2C into the change in voltage. That would be 5 by 3. So the value would be 10 into 5 by 3 delta t I should have written. So both the values would be same only. Why it would be same? Because at t equals to 0 plus, this is also providing very low impedance and this is also providing very low impedance. So the complete current is flowing like this. So IC1 is equals to IC2, right? Both are in series. So IC1 is equals to IC2. What about IR? What about IR? IR0. This is not IR0 plus. What about IR0? IR0. Tell me what is the value of IR0? 0 ampere, because at t equals to 0 plus, there is infinite frequency, and at infinite frequency this will provide very low impedance, this will provide very high impedance. Since this is providing very high impedance, that means no current will flow through this. All the current that is coming from here, that will flow through the capacitor. So IR0 is 0 ampere. Now let's see what is the circuit at t equals to 0 plus. Now this is the most important part. So take your complete concentration here. Okay. Circuit at t equals to 0 plus. Here I am having 5 volt. My this capacitor is charged, already charged to how much voltage? 10 by 3 volt, right? 10 by 3 volt. I have a resistor and I have a capacitor here. And this capacitor 2C is charged to 5 by 3 voltage, right? This is the circuit at t equals to 0 plus, and this is my resistance R. Now tell me, this 10 by 3 voltage will come across the resistance R as well, right? The same voltage will come across the resistance R at t equals to 0 plus. That means at t equals to 0 plus, what is the current flowing through the resistor? That is 10 by 3 into 1 by R, that means 10 by 3 R. So V by R current is flowing. So what is V? V is 10 by 3. So 10 by 3 R ampere current is flowing in the resistor. So IR 0 plus is 10 by 3 R ampere. Now we have to find IC 0 plus, IC 1 0 plus I need to find, and IC 2 0 plus I need to find. These two values I need to find. Okay. Now let's see. Tell me how many sources are there. How many sources you can see in this circuit? Sources, energy sources. This is a voltage source, this is an energy source. Now since there is one current there is current at t equals to 0 plus. I am talking about at t equals to 0 plus. Circuit at t equals to 0 plus. There is this current 10 by 3 R. This is also an energy source. There is this voltage. This is also acting as an energy source, and there is this also this voltage is also there. This is acting as an energy source. So at t equals to 0 plus, there are 4 energy sources. What are those energy sources? Input voltage VC1 0 plus, VC2 0 plus, and IR 0 plus, right? So basically 5 volt, 10 by 3 volt, 5 by 3 volt, and 10 by 3 R current. Now all of the 4 will contribute in IC1 and IC2, right? Let's just assume there are 4, any circuit is there are 4 energy sources. So every energy source can contribute in current, right? So all these 4 energy sources will contribute in IC1 and IC2. So here I can write all 4 will contribute in IC1 and IC2 0 plus, especially at 0 plus. Everything is happening at t equals to 0 plus, right? Now I need to find IC1 0 plus and IC2 0 plus. What I will do? 4 energy sources. What I can do? Superposition. Apply superposition. I should have written like this. Apply superposition. Okay. So what I am doing? Considering only IR 0 plus first. Considering only IR 0 plus. So only this current I am considering. Okay. forget about all other thing. So the voltage source will be shorted, then I have a capacitor, then I have a current source here, right? A current source here, that is 10 by 3R. Right? This is the case, and this is C, this is 2C, right? C and 2C. Now there is this 10 by 3R current, okay? This 10 by 3R current will come here and it will see two capacitance. One is C, one is 2C. Look, this plate of capacitance C is connected to this node. This plate of capacitance 2C is connected to this node. The other plate is connected to ground and the other plate is connected to ground. So simply, isn't it like this? A current source that has C and 2C. Now, what is your IC1 direction? IC1 direction is this, right? IC1 0 plus. And I can't call it IC1 0 plus because I am applying superposition theorem. So I have to call it something else. Let's just call it I dash C1 0 plus. And this was your I dash C2 0 plus. So tell me, in this circuit, this current is 10 by 3R. Now in this circuit, how should I make IC dash 0 plus? I dash C1 0 plus. How should I make I dash C1 0 plus? Like this or like this? A or B? B, right? Why? See, what is this 10 by 3R current is flowing that way. This 10 by 3R current will be flowing that way. But the IC1 dash is coming in the other direction, right? So this is your IC1 dash. IC1 dash 0 plus, and this is your, in the same direction, IC2 dash 0 plus is there, right? And this is your IC2 dash 0 plus. So tell me, what will be your IC1 dash 0 plus? That will be 10 by 3R. The current is always divided in proportion, not in inverse proportion, right? Current is always divided in proportion of the capacitance. So 1 by 3. But negative sign will be there because the current direction will be like this. So minus 10 by 9R. And IC2 dash 0 plus would be what? That would be 10 by 3R into 2 by 3. (20 by 9R). So these are the values at t equals to 0 plus. Did you? Okay. This is not the complete value. There are other sources as well. So did you understand what did we do? 10 by 3R current is flowing. Okay. Now 10 by 3R current will see two capacitance, C and 2C. So it will be flown in C, it will be going in the proportion only. So 10 by 3R into 1 by 3. But the direction I am taking in this direction. So there will be negative sign. And in 2C also it will go like this. But the direction is the same only. So this is the value. Are you getting my point? So now I consider only IR 0 plus. Now considering rest of the sources. Now I will consider rest of the sources. Considering rest of the sources. Now this current will be 0. This current IR 0 plus is 0. That means I am considering all other sources, just IR 0 plus will be 0 ampere. Okay, so tell me now what will be the case. I am having a 5 volt here. This is capacitor C. This is capacitor 2C. The C is having 10 by 3 volt and this is having, okay, this was having 20 by 3 volt, I guess. No, 10 by 3 only. And this was having 5 by 3. Sorry. This was having 5 by 3 volt. Now this current I need to find IC1, IC double dash 1, IC double dash 1, and then this current I need to find IC double dash 2 at 0 plus, at 0 plus. Tell me what will be the value. We have seen the switch capacitor. Tell me what will be the value of IC1 0 plus and what will be the value IC2 0 plus. 0 ampere. Circuit is in the steady state. 5 by 3 here, 10 by 3 here, 5 volt here. Will there be any charge distribution? There will not be any charge distribution. Circuit is already there in steady state, right? If you see, if you start from here, 0 plus 5 minus 10 by 3 minus 5 by 3 equals to 0 volt. So there is collectively 0 volt in the circuit. Collectively there is 0 volt in the circuit. So no charge distribution will be there. The circuit is in steady state only. The circuit is in steady state. Like if you remember, I have told you to write the method. I have told you a method to write the capacitor voltage. What is that? Let's just assume I am writing VC2. That means I will write the initial voltage plus total voltage present in the circuit, that is 0 only, into divide in inverse proportion. So final answer I am getting is 5 by 3 volt. So initially 5 by 3, final also 5 by 3. So what will be my current? What is the current? C dVc by dt. This voltage is not even changing. So C into 0. So what will be the current? 0 ampere. Or you can simply see the circuit is in steady state only. There is no charge conservation. If there is no charge conservation, that means the current will be 0. So IC1 double dash 0 plus and IC2 double dash 0 plus is 0 ampere. Okay. So simply what will be your IC at t equals to 0 plus? IC1 at t equals to 0 plus. So basically your IC1 at t equals to 0 plus is coming out to be this current, that will be minus 10 by 9R, and IC2 0 plus is coming out to be this current, that is 20 by 9R, right? And what will be the condition at infinity? What will be the condition at infinity? Circuit at t equals to infinity. What will be the condition at infinity? At infinity, this will be open circuited, this will be open circuited. So IC1 and IC2 both will be 0, right? Both the capacitor will be open circuited, so the current will be 0 only. IC1 is equals to IC2 is equals to 0 ampere. So tell me, how will the graph go? For IC1 we will draw, for IC2 we will draw. Right? So for IC1 and IC2, initially there is an impulse, that is 10 C by 3. So initial impulse is there, that is 10 C by 3. C by 3. C by 3. And then IC1 at t equals to 0 plus is negative value, minus 10 by 9R. That is minus 10 by 9R. And then it decays down to 0. So exponentially it decays down to 0. Well and good. And what about IC2 at t equals to 0 plus? 20 by 9R. 20 by 9R is somewhere. It can be lesser than this as well. It can be more than this as well. You can't really comment. So it is 10 by 9R. It will go like this. Okay. And what is the time constant? What is the time constant of the circuit? R into C plus 2C, so 3RC. Time constant is 3RC. And what is the time constant here? That is also 3RC. Understood? let me tell you again how did we solve it. Okay, I saw the circuit. I got to know that there is initially impulse current. So I can found the value of impulse current. How? I will just see what is the change in voltage. The change in voltage is 10 by 3 volt, and for the second capacitor the change in voltage is 5 by 3. So simply I will, from CV delta T, I can find the value of impulse current. So C is my C only, and change in voltage is 10 by 3. So 10 C by 3 delta T. This is my impulse voltage, impulse current, and similarly for IC2 as well. Now at T equals to 0 plus, I am seeing 4 sources. Value of voltage across capacitor C, value of voltage across capacitor 2C, and there is a battery of 5 UT, and then there is a current in resistor, that value was 10 by 3R. Now because of all these 4 sources, there will be some current. Okay, so first I check by 10 by 3R. So 10 by 3R, the 10 by 3R current will be divided in C and 2C. So C will have 10 by 3R into 1 by 3, that means 10 by 9R, and 2C will have 10 by 20 by 9R. Okay, 10 by 3 into 2 by 3, so 20 by 9R. Since the direction of IC1 is this, but the current is flowing in the opposite direction, so I had to write minus 10 by 9R, and for IC2 dash I had to write 20 by 9R. So initially at T equals to 0 plus, this will be the important concept in the interview. Okay, this will be a very important question in the interview. They will ask you the value of current at T equals to 0 plus, and if you say this is the impulse current, your interview will be over. Okay, so the current at T equals to 0 plus is not impulsive. At T equals to 0, the current is impulsive. The value of current at T equals to 0 plus is minus 10 by 9R for IC1 and 20 by 9R for IC2. Okay, then I also need to check by 5 volt, 10 by 3 volt, and 5 by 3 volt. When I consider all the sources at one time, I got to know the circuit is in steady state only. So there is 0 ampere current because of these voltages. So only the current that was coming because of this 10 by 3R current, because of the current through the resistor, that is my final current only. So minus 10 by 9R is my final current, and 20 by 9R is my final current at T equals to 0 plus, and then it will decay down to 0 ampere. So initially an impulse, then initial current minus 10 by 9R and decays down to 0, and 20 by 9R and decay down to 0. The time constant being 3RC. Okay, well and good. Now try this question on your own. Not by voltages. For finding the current at T equals to 0, you can use voltage. Okay, because the current would be CV delta T at that time, right? But for T equals to 0 plus, you don't need to use voltages. Okay, so in this circuit, for voltage waveform, what happens? I hope all of you know. Let's just call it this one as VC1 and this one as VC2, right? So tell me, what is my VC1 at 0 minus? That is 5 volt. What is my VC2 at 0 minus? That is 0 volt. What will be my VC1 at T equals to 0 plus? If you don't remember it, you have to go and read the notes. Here I am having 5 volt, here I am having 0 volt. The complete circuit will be shorted, infinite current will be flowing, and the value of the capacitor voltage will be changing all of a sudden. So what will be the value of capacitor voltages? That would be 5C upon 5C1 upon C1 plus C2. So 5C upon C plus 2C, simply by charge conservation. So it would be 5 by 3 volt, right? So from 5 volt to you are going 5 by 3 volt, and the same voltage will be for C2 as well, right? So what will be your IC1? Yeah, one more thing to notice here is that IC1 current is in this direction. That means it will charge 5 volt capacitor. But what is happening? You are losing your charge, right? So IC1 at T equals to 0, what it would be? Initially you had 5 volt, finally you are having 5 by 3 volt. So 5 by 3 minus 5, right? 5 by 3 minus 5 into capacitance C delta T. So the current will be negative. Why so? Because this is discharging the capacitor. So it will be minus 10C by 3 delta T, right? Negative impulse is there. And IC2 at T equals to 0, what it will be? From 0 to 5 by 3 it is going. From 0 to 5 by 3 it is going. So 5 by 3 into capacitance, that would be 2C delta T. So it will be 10C by 3 delta T, right? Now see the circuit at T equals to 0 plus. Circuit at T equals to 0 plus. This is the similar kind of circuit, nothing different is there. Okay. So there is high chance that you can solve it on your own. This is R, this is C, this is 2C, and here I am having 5 by, no, not 5 by 3, yeah, 5 by 3 volt, and here also I am having 5 by 3 volt. And because of this 5 by 3 volt, what will be the current in the resistor R? That would be 5 by 3R. At t equals to 0 plus 5 by 3 volt here, 5 by 3 volt here, that means 5 by 3R current is flowing in this resistor R. So now there are three sources, 5 by 3 volt, 5 by 3 volt and 5 by 3R. So we have to consider each one by one. Okay. Yeah, so here you got to know that your IR 0 plus is 5 by 3R. Right. So the condition is something like this. This is charged to 5 by 3. And then I have a current. This all is happening at t equals to 0 plus. Okay. 5 by 3R. So whenever there is a case of infinite current, something different will happen at t equals to 0 plus for sure. Because if there is infinite current, that means the capacitors are instantaneously charged. If the capacitors are instantaneously charged, that means there will be some current in the resistor as well that is connected to parallel. If there is some current in the resistor as well, now that current that is there in the resistor, that has to flow through the capacitors. So the value of current will change. So at t equals to 0 you are having impulse current, but at t equals to 0 plus you will be having some finite current, and that value we are going to find now. Okay, and this 2C is charged to 5 by 3. So there are three energy sources 5 by 3 volt, 5 by 3 volt and 5 by 3R. Now by seeing the circuit, by watching the circuit, can you tell me which sources will result in zero current? By seeing the circuit, can you tell me which sources will result in zero current? 5 by 3 volt and 5 by 3 volt. When both of them will act together, when both of these act together, they will result in zero current, right? What do I mean by that? Zero current. What do I mean by that? I will consider only 5 by 3 and 5 by 3 volt. I will not consider this current. So what will happen? Here at capacitor C I am having 5 by 3 voltage, and at this capacitor 2C I am having same 5 by 3 voltage. This current is 0. That means this will be open circuited. So tell me, will there be any current? No, there will not be any current because the circuit is in steady state. Right? What is the total voltage in the circuit? From here 0 plus 5 by 3 minus 5 by 3, 0 volt. So there is 0 volt in the circuit, so the circuit is already in steady state. So these will not contribute in the final current. Only this current source will contribute in final current. So 5 by 3R will, so now 5 by 3R current. Now what was my direction of IC1? IC1 direction, this one. IC1 at t equals to 0 plus, and this was your IC2 at t equals to 0 plus, will give 5 by 3R current will result in IC1 0 plus and IC2 0 plus. So can you tell me what will be IC1 0 plus? This 5 by 3R current is there, that will be divided in C and 2C. So IC1 0 plus would be 5 by 3R into 1 by 3. Is that correct? No, negative sign, because this current is flowing in this direction, right? This current is flowing in this direction. So the IC1 should be in this direction. So since the direction of IC1 is opposite, so there will be negative sign. negative sign. That will be minus 5 by 9 R ampere current. Also, you can understand by one point that in this case, capacitor are getting discharged. So the current has to be negative. Both the capacitor are getting discharged. Eventually, what will happen? If you remember the circuit, what will happen eventually? Both of the capacitor will have zero voltages, right? All the current will be discharged through the capacitor. Sorry, all the current will be discharged through the resistor. So both of the capacitor will have zero voltages at steady state, right? So at steady state, if both of the capacitor are having zero voltages, then it has to discharge. So the current has to be negative. Similarly, IC2. The direction of IC2 is this, but the current is flowing in the opposite direction. So IC2 0 plus is minus 5 by 3R into 2 by 3. So it would be minus 10 by 9R ampere. And at infinity, all of you know, at infinite, IC1 at infinity would be equals to IC2 at infinity, and that would be 0 ampere. So initially an impulse, then a negative voltage, that is dying down to 0, right? So now we can draw the waveforms. IC1, what was your IC1 impulse at t equals to 0? That was negative minus 10C by 3. Negative minus 10C by 3. And this was positive, but the value was same, plus 10C by 3. This was minus 10C by 3. This was 10C by 3. Actually, this is not written like this. Here we don't write delta t. Okay. Here we only write the area. This shows the area, right? So this shows the area of the impulse. So here we only write the area. We don't write delta t. Okay. This is self-understood that it will be impulse only. So they can consider delta t there. Okay. Now what is IC1 at t equals to 0 plus? That is minus 5 by 9R. Minus 5 by 9R. Let's just assume this is minus 5 by 9R. So it decays down to 0. Minus 5 by 9R to 0. Right? Exponentially. And for this, let's just assume this is minus 10 by 9R. And then it decays down to 0. What is the time constant? Tell me, what is the time constant? R and both are in parallel. So 3RC. 3RC, and here as well it is 3RC. Well and good. Understood the question? Okay. What we did? First, there is instantaneous change in the capacitor voltage. That means there is impulsive current. Impulsive current we can find by the change in the charge. So the change in the charge was for C1 it was minus 10C by 3. For C2 it was 10C by 3. So 10C by 3 delta T is the current. Okay. Then at t equals to 0 plus, we saw that there is 5 by 3R current in the resistor. So the same current will be, so there will be two paths for this 5 by 3R current from C and from 2C. So in C the current will be going 5 by 3R into 1 by 3. So 5 by 9R, but there will be negative sign. And same for the capacitor 2C, the current would be going 5 by 3R into 2 by 3, but there will be negative sign. Okay. And then it will decay down to 0. That's it. Okay. So it was a very, very important concept and very conceptual concept, right? Okay. So now in the next video, this is just a 35-minute video. So, okay, then in next video, we will see the second order circuit. Okay. And we will see this by the concept of damping. So I hope you remember RLC circuits. There we studied 4 kind of damping, RLC and LC circuit. So in RLC we studied 3 kind of damping, that was underdamped, overdamped, critical damped, and in LC we studied undamped. So that concept will be used here. Okay. So by damping we will understand, and then later on we will understand the time domain analysis, and that will be a very, very complex concept. Okay. This will be easier. Okay. Damping one. But that time domain analysis will be a complex concept, but I will explain it very very precisely. Okay, so let's meet in the next video and we will study about the second order circuit by damping. Okay.